Rightio, good morning, guys. Today we're going to be starting looking at chapter 9, and I'm going to be introducing to this concept of adding payments to loans or to investments. Now, you often hear kids complain about how they're never taught anything important in school. Well, guess what? This is the shit that's actually important, because this actually is real life. This is how loans work in real life. What we've looked at so far with the simple and compound interest rates aren't really realistic in terms of a loan, because you don't take out a loan and then pay all that money back at the end of the life of the loan. You pay the loan off in installments over time. All right, so reducing balance loans takes into account those repayments that you are making. Okay, so your loan still earns interest that you have to pay back. Again, this is how the bank makes its money, but your repayment then pays off part of that interest along with part of the principal. So if we have a look over here at this graph, what happens in a reducing balance loan is that you start off with an amount that you borrow, say $450,000. Now you're going to get charged interest at a particular rate, either compounding monthly or quarterly or whatever. And you're going to get charged interest at that rate. So if it's compounding monthly, then you're going to get charged interest every month on that original amount. So in this case, the interest being paid to begin with is $2,250. And you're told that you need to pay a repayment of $3,797. Now, that payment that you're making is bigger than the interest that is going to be charged, because you need to be able to pay off both the interest and some of the original amount that you borrowed. So the payment has to be bigger than the amount of interest that you're being charged. So we can see here that we get this thing called a principal reduction. So that's how much of your payment actually comes off the amount that you originally borrowed. That's how much in this case is going to come off your $450,000. Only $1,547 of your original $3,797 is going to come off that amount. So we then get a new balance. Now, from this new balance, you're then going to be charged interest again prior to you making your next payment. So you'll notice, though, that the interest rate is going to stay the same. So the interest that I'm now being asked to pay is going to be a smaller amount, because the overall total, my overall balance, has reduced. So the total of interest that I'm now paying is going to also reduce, but I'm going to make the same payment, which means that a larger amount of money is now going to come off my balance remaining, because the interest that I'm paying is less. And that's why we get this graph up here. So over the life of a loan, the amount of money that we pay off the principal is going to increase. Okay, so that's this first graph. That's this first one, the first blue line. That dude there. That's the amount that we're paying off the principal. Each time we make a payment, we pay more and more off the original amount that we borrowed. Okay. The overall life of the loan is then going to decrease. And the interest that we're paying is going to eventually flatten out, because the amount that we owe is going to get much, much smaller, to the point where we're not having to pay very much interest at all, because we owe such a small amount of money. Okay. Now, just so you know, this is how credit cards get you. If any of you guys have a credit card, you get a credit card statement at the end of the month, and it says this is your minimum payment. I know you might owe $1,000 on your credit card. I don't know how you guys shop, but the minimum payment might be $200. And what that minimum payment does is that minimum payment barely covers the amount of interest that you're being charged. So in this case, the minimum interest to be paid on this account would be $2,250. That would be the minimum payment because that pays off the interest that you have been charged. So if you don't pay any more than that, then your balance remains at the amount that you have borrowed and it never actually decreases. So you're continually paying off this loan, but you're never actually paying off any of the money that you've borrowed. You're just paying off the interest that's being charged. So that's why you should always pay off more than the minimum amount so that you're actually reducing the amount of the balance, and therefore the amount of interest that they're going to charge you will be less, and your payment is actually going to cover more and more of that amount. We're going to look at this a bit more when we do amortization tables tomorrow. But for now, we're going to be looking at joy and bliss recurrence relations. Yay! So a recurrence relation includes both a payment and an interest increase. So it's going to contain both an R value and a D value. But in this case, our D value is just going to be how much you're paying off, whereas our R value is going to consist of the interest rate. So it's a combination of our simple and our compound interest formula from the previous chapter. All right. The way that we're going to recognize reducing balance loans is we're looking for keywords in our questions. So blah, 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 blah. The first thing that I want to identify here is this whole regular monthly repayment. That is what we're looking for as the very first thing that is going to identify a chapter 9 question versus a chapter 8 question. Is there a regular repayment? So because we have a regular repayment, it's going to be either a reducing balance loan, an annuity, or an annuity investment. Now, at the moment, we're doing reducing balance loan, so it's going to be a reducing balance loan. The other good thing about reducing balance loans is usually in the question, it'll say it's a reducing balance loan. Now, the other thing we need to look at when we do to identify a reducing balance loan is we're looking at keywords that indicate the directional flow of money. Right? Money can either be positive or negative depending on its flow. So in here we see that Netta is borrowing the money. That means that Netta gets that money. When you get money, that makes you happy. So that makes it a positive thing. And in a loan, you're going to borrow money and it's going to come to you and that's going to make you happy. Now, this is not important just yet, but it will become next week when we start using our CAS calculators to solve these things. So the fact that we're borrowing money here, that is a key word that we're looking for because this is a positive word. Plus VE, positive. Okay. Righto, next bit of information we have, I've got $20,000 and 7.25% compounding monthly. All right, cool. So now I can go about setting up my recurrence relation. I know I have to work out a recurrence relation because the question says recurrence relation. If it doesn't say recurrence relation, well then don't do recurrence relations because they're a pain in the ass. Right, so my formula up here says that I need to have a principal, V0. So the principal is the amount that you're borrowing, and I've spelt it wrong. I spelt it as in Mr. Rule principal instead of principal amount of money, whatevs. And then I'm going to have Vn plus 1, so the next term equals R times by Vn minus D. Now I've highlighted R and D up above because they're the only two values you need to substitute into your formula along with your principal. So I need to do a calculation for R. So R equals 1 plus little r divided by, little r divided by T, all divided by 100. So in this case, it's going to be 1 plus, little r is always going to be my rate, so 7.25. T is the number of times it's compounding. So in this question, it's compounding monthly, so I'm going to divide by 12, and then divide everything by 100. Alright, so I get an R value, 7.25 divided by 12 divided by 100 is 1.006. Let's go with that. Alright, my D value is just the amount of the repayment, which in this case, we're told we've got a regular repayment of $200. So now I'm going to chuck my R value, my D value, and the principal into my equation. So my principal is the amount that I'm borrowing. That's going to be 20,000. Vn plus 1, I'm going to substitute in my value for R, 1.006 Vn, and I'm going to subtract the amount of my payment, which is 200. All right. So in this case, because the interest is compounding monthly, N represents the number of payments, and the number of payments should equate to the number of times your interest rate is compounding. So if it's compounding monthly, you should make monthly repayments as well, because you want to pay off your interest at the same time as it's being compounded. You don't want to wait 2 months and then pay it off, because that's then going to increase the amount. So the amount remaining after 5 months is the same as 5 iterations. So we're going to perform 5 iterations on our CAS. So I'm going to set this up. We're going to start on our CAS with our $20,000. And you're going to hit enter so that that's already in the calculator. Now, without pressing anything else, we're just going to type in what I want to do with this equation. So I'm going to times it by 1.006 and then subtract 200. So times it by 1.006, and then I want to subtract 200. And if I just hit enter, it's going to do it for me automatically. That's 1 iteration. Press enter again, 2 iterations, 3, 4, 5. And because this is money, we should always put money to 2 decimal places. Alright, so after 5 iterations, our balance is going to equal 19,595 and 17 cents. Perfect. All right. Okay. So this example is setting up your occurrence relation and then using it to answer questions. Our next example is where we are given the recurrence relation, and then we have to work backwards to work out some other stuff. All right, so we're going to use our calculator to determine recursively. All right, so that's telling us we have to use the recurrence relation. We're not allowed to use a rule or anything else at this stage. We have to use a calculator. So with my calculator, so we've got 3 repayments. That's going to be 3 iterations. Alright, so we're starting with $4,000. So let me just type 4,000 in here. 4,000. And it's important that you press enter first before you start telling the calculator what it is that you want it to do. So for this one, we want to times it by 1.008 and then take 873.69. So times it by 1.008 and then take 873.69. All right, there's after 1 month, 2 months, 3 months. Actually, we don't even know that it's months. We just know that it's 3 repayments, so 3 iterations. All right, we don't actually know the time period of this yet. Okay, so 145468. All right. Determine the annual rate of interest. Not compounding, it's an annual rate. So this is asking us to find little r. And if it's an annual rate of interest, then that means that t must equal 1 because it's annual. So we know from our equation above that r has to equal 1.008. We also know that r is equal to 1 plus r divided by t, which in this case is going to be 1, divided by 100. So we can then solve this on our CAS. So menu, algebra, solve 1.008 equals 1 plus some r value divided by t divided by 100. Now t is 1, so I'm not going to put that in. I'm going to solve for r. There you go. R is equal to 0.8%. Well, that's a bullshit rate. All right. How much will the final payment need to be to ensure the loan is fully repaid after 5 payments? Okay. So to do this, we're going to see how much is owing after 4 payments. We just want to check how much is owing. So I've already done, at this stage, I've already done 3. Let's see if my thingy will keep going. No, dang it. I'm going to have to go back up and start again. So I've got 4,000 times by 1.008, take away 873.69. All right, so 1, 2, 3. So there you go. After 3 payments, I still owe $1,454. Oh no, I want 4 payments, don't I? There you go. So I now owe $592.62. So yes, good. So I still owe that amount, whatever the hell that was, 592.62. Right, now there's 2 ways that we can solve this actually, because that amount that's still owing is still going to incur interest. So we need to add interest onto that, and that will be the final amount that we pay. And the interest is calculated by 1.008. So it's going to be $592.62 times by 1.008 will give me how much I need to pay off on the 5th payment. So I'm going to take this amount, times it by 1.008 to find that I still then owe $597.36. Now, the other way that you could do that, oh no, because we want to pay it off in 5 repayments, exactly. So my 5th payment has to be $597.36. Yeah, that's probably about as tricky as that stuff can get. Right, so we don't need to go on now for the amortization tables. We're going to look at that tomorrow. But you do have some exam questions here to have a look at on reducing balance loans. Only 3 there to have a go at. Alright, and amortization tables tomorrow is going to be this dude here, how we set that up. Alright, all done.